Hello and welcome to NARC Live on Wednesday the 24th of January 2024. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G7URP. Lovely to see you. On tonight's show, we find out about the effects on propagation caused by the October 2023 solar eclipse with Gwyn G3ZIL. We see where some of the money raised by you for charity in 2023 went to. And we find out what on earth this is. And this has got a very interesting twist to it, which we'll tell you later. But we've had some entries.
Will we?
Well, yeah, I think we should explain the twist, but we'll do it later. If you haven't already sent us an email, and quite a few of you have, just put it onto BATC or Facebook and we'll include your answers when we get to that part of the show. Okay, but we start with club news. And as we mentioned in the menu at the top, last year, the club at the AGM decided to always decides who they're going to support with fundraising efforts through the year in terms of charities. And for the first time, I think ever, we had a draw. And so the club decided to raise funds for both Norwich Fan Club and Diabetes UK. Now that is our calendar year, so the money raised was mainly from Barford 2023, where we did a raffle, and also at the Christmas dinner we had a Secret Santa dinner, and a total of £900 was raised. Actually, it was £899 if we're really precise. And we thought, well, we'll top that up to £900. So that's what we raised for those two charities. Well, as it happens, on Monday, the Fab Club in Norwich met. And not only were they meeting, but one of the people who sponsored them, which was Steve, G3EVA, was going there to play, as he often does, at least once a month for them as well. And of course, one of our members, Merv, G0HZP, was also there. So we thought this would be a great opportunity to present a cheque to them. And this is what happened.
Have a presentation. David Palmer from the Norfolk Amateur Radio Club is presenting us with a cheque. Whoa, yes. And this is because Steve, who's also a member of the Norfolk Amateur Radio Club, put our name forward, and the members of the Norfolk Amateur Radio Club very kindly raised money for us during the last year. So, David, can I just hand over to you for a minute just to say a brief word about your club?
I should also mention, hello everybody, I'm David, and as well as Steve is a member of our club, Merv, I was just going to say that Merv is also one of us. Can you hear me now if I speak up a bit louder? Can you hear me? Okay, so just briefly, I'll just briefly... Okay, so just to tell you very briefly about what we're about. We're like you, we're a club, we meet every other week, and the Norfolk Amateur Radio Club, unlike the radios that you listen to music on and things during the week, we're all interested in radio, how it works, we make different radios, and we communicate with each other locally or even around the world. So that's what we do as a hobby, and every year we raise money for various charities, and we ask the members to put forward different ideas for different charities. And last year, both Merv and Steve nominated the Fab Club for that. Now, we had to put this along with other suggestions to our members, but we voted, in fact, it was a draw, I'll be honest with you, so half our money was going to go to Diabetes UK, which I'm sure you'll agree was a good cause as well, but it was a dead draw, so the other half is going to go to the Fab Club. So I'm delighted to tell you that our members, throughout the things that we've done during the year, we did a raffle at Christmas and we did other fundraising at Barford, we raised a total of £450.
All right. Yeah, let's have you both in this. Right, can you go further back? Is that okay? Yeah. Blame the photographer. Get close. Yes, look happy. Yes, oh wonderful. One of those must come out okay. That's brilliant. Thank you ever so much. Now, David, we also have something for you. We have the Fab Music Award for the best supporters to Norfolk Amateur Radio Club. And we have a card here. Please show that to all of your members. Inside there's a bit explaining about what we do at the club. Thank you very much indeed.
All right, thank
Let's
you.
have a huge round of applause. Right, no further ado. It's time for the card game.
There we are. It was really quite touching to go there, really, and just see, because that £450 will make a big difference to that club. Like many organisations, they've struggled in the last few years where they used to get grants and things from the council. They used to be able to meet in a hall which was no charge. They now have to hire that venue at Helsden. So it was lovely to see them together, what they did. Wonderful to see Steve entertaining them, and there's a different entertainer. They meet every single Monday night at 7 o'clock, and it's open to all from what we can see, and there's no charge at all for those people. So that £450 really will make a huge difference. And I will just read that card. They did, as you saw, I didn't know this was all going to happen, but it was very, very unrehearsed. We didn't really know what was going to happen. And this is the card, which is a lovely card they gave us. And they said there, "Dear David, please extend grateful thanks to Mark, Steve and all the members of Norfolk Amateur Radio Club for your extremely generous donation of £450 to Norwich Fab Club. We have to raise all our own funds, and without your support would be unable to provide support and a social club for local people with physical and learning difficulties. Thank you for all your help. Kind regards, Martin Fuller from the Norwich Fab Club." So thank you all for being a part of raising all that money. As I mentioned as well, of course, £450, another £450, the half of it, was also for Diabetes UK, and we'll be meeting one of their representatives very soon in the next couple of weeks or so, and I'll let you know more details nearer the time. I think it's going to be on the 7th of February, which will be at a meeting at CNS. And in fact, we won't be meeting here online before then. So watch out for details anyway. It's just that the person is yet to actually confirm the date with me. So we'll find out a little bit more about them as well. But then again, once again, thank you. And it meant a lot for us to go there and see how that money will help change lives. Now, on to some details about the club. And in 2 weeks' time, there's a tabletop sale on Wednesday, the 7th of February. We're giving you lots of notice, and this one's a little bit different. So we'll be holding our first tabletop sale of 2024. It's free to attend, buy and sell for all paid up members. So that's another hint to you. Please make sure you've paid up to be a member. If you have, you can come to this and do the whole event, selling and everything free. But more than that, we're going to try something different that the club hasn't done for a very, very long time. I think it's 20 years plus. And that is we're going to have a fun auction as well. Mark G0TMT has kindly offered to be the auctioneer for the night. So if you've got something that you want to sell, but you don't want to have a little stand there and you'd like it to go to auction to find out what it can be raised, then Mark's the auctioneer and we'll try and get the best price for you there that night. So put the date in your diaries now. It's 2 weeks' time. It's Wednesday, the 7th of February, and we'll be having an auction. It's free and everything, no commission or anything like that. We're doing it kind of for fun, but also to make it an interesting evening. And of course, if you are members, then all of this is free. It opens between 7 and 9:30, and the auction will start at about 8 p.m. And if we do get a representative of Diabetes UK, they're going to do that at about 7:30, but I'm yet to confirm that. All right, so we look forward to that as well.
Do you think that anybody would buy any model trains? Because I think there's quite a few of them.
We're not allowed model train, no.
Okay.
Do you really? Got to watch what was taken that night. Yeah, make sure you've got permission to sell what you're... Yes, right? Make sure you've got permission to sell what you're going to put up to the auctioneer. I don't want to see some of my stuff up there. So, there. Anyway, now, as you know, the club owns lots of equipment, and most of that is available to you, members, for loan. But, and we own 2 very, very nice filters, which normally come out at most field days. But the boxes they were in were very tatty. So when Peter M0RYB borrowed these, he wrote a note to me and said, the boxes are really tatty now and everything, and could I make a nice wooden box for them? And look what he did for us. There's the box. I mean, that's fantastic. He's made this custom to fit. And if we show the next picture, Tammy, that's, you can see there's the 2 filters, 1 in each half there. Beautifully made. I think people will be giving you orders of things to make for them now, Peter. So thank you ever so much for doing that. I wanted to give it a bit of prominence here because that is a very nice thing to do, giving back to the club. And that's really going to help look after those instead of those tatty boxes that they used to be in. Thank you. And one other bit of news to tell you about something that's coming up, not strictly speaking a club night event, but it's the Norwich Science Festival, which is on between the 17th and 24th of February. It's 8 days. It's a massive event. And the club, because we feel, well, we are a scientific hobby, we are going to put on a small stand, a bit like you see there in that area, in the Forum in Norwich. And we've booked a stand for Monday, 19th of February, because that is the Tech, Innovation and Engineering Day, and that was best fitted to the 8 days of the themes that they've got going on. Now, we already have a few of us taking part. Jim G3YLA, Mark G0LGJ, Tammy and myself will be there all day. So we don't need too many more volunteers. What we would love is ideas to show. We're going to show things like resonance. We're going to probably show a crystal set because a lot of the visitors there are youngsters and they'll be fascinated with with a receiver, radio that means no batteries. Morse code, we have to show a bit of that, give them a certificate when they send their name in Morse code, that sort of thing always goes down well, particularly with youngsters. And we're going to hopefully make a Tesla coil and safely demonstrate spark transmitters. At least that's my idea. I hope the heck that works. I've written the risk assessment, so it better work. Anyway, the serious point is your club will be represented on there on Monday the 19th of February. And if you've got an idea of something we could show on one of our 2 tables to demonstrate radio in a scientific way and the science behind it, then please let me know. The usual address, radio@dcpmicro.com. And we will talk about it and hopefully we'll feature it and maybe you'll come along as well and show it on that date. Now, on to members news. And Kevin M0KKM, who's a member of the King's Lynn Club, but he's also a member of NARC, asked me to mention that tomorrow, the 25th, the King's Lynn Amateur Radio Club are having a talk about the Voyager spacecraft. As normal, he says, it will be held in the Scout Hut and doors open at 7 o'clock with entry £1, which includes tea and bickies. All right, so that's the King's Lynn Club tomorrow night. A talk about the Voyager spacecraft. Have a look at their website if you want any more details about how to find them. And finally, from Club News, we've got a message from David M6DPZ. As you know, we do encourage you to send in your pictures, your videos, your news. And this very windy week we were very thrilled to receive a very topical video from David entitled Twister over Norfolk. I won't say any more. Here it is. Very good, David. You had us going because I thought that was going to be a Twister over Norfolk. There is an ice cream called a Twister, just in case you don't know that, and that doesn't make any sense at all. There is an ice cream called Twister. Very good, David. You had me going and everybody else, I should think, watching that as well. Thanks very much for sending you that. Don't forget to please keep sending all your details, your news stories, fun bits like that. We love to see them as well. And send them to radio@dcpmicro.com, as here. Now, we're going over to Tammy for your little people. Tammy, who have you chosen this week?
Here's the little people this week. Have you ever wondered why you can never find any tape when you need any? This is
Lots
why.
of things. Oh, tape. That's where the insulation tape's gone.
Yeah.
That's good, isn't it?
Little race cars.
And a paperclip at the front and a ruler at the back. Really good.
Bulldog clip.
A bulldog clip, sorry, yeah.
Get it right.
Miniature-calendar.com. It's the Japanese website that puts a new picture up every day. Intriguing how they think of all these different things. We've been doing this for 3 years now, so goodness knows how long, how many there are on there.
They've been doing it about 10 years or so.
Have
I
they
think.
really?
Yeah.
A new one every day? I would be
Yeah.
seriously challenged to think of new ideas there. Anyway, miniature-calendar.com. Thanks very much. So, as I said, please keep in touch with us about what you're doing. Now, it's on to that competition. Let's have a look as well and see if anybody...
I don't think
anybody
anybody
A few people are
has.
saying they look legit.
I think that
Everything
was
else-
the Twister.
Yeah, that was the Twister video, wasn't it? Yes, I think that you fooled quite a few people there, David, with that. Anybody entered into this?
No, there isn't. No.
Right. Well, let's go through the answers from people, entries from people, and then we'll tell you something special about this at the end. This is the object we said, what on earth is this? Bruce G4KZT says, I reckon the latest what on earth is a clip to hold specs to a car sun visor. Particularly useful this time of year for sunglasses as the sun is so low in the sky.
Bob G6PWS. The item is a sunglasses or just glasses holder. It clips either onto the sun visor or any other place, easily accessible whilst mobile. I have one attached to my heated dash air vent.
Bob GSTU says, my guess is it's a sunglasses holder clipped to the interior trim. Mine looks the same as that.
Paul G3VPT, another difficult one. Is it a clip-on light used by cyclists?
I can see that. And Andy M0NKR says, this week's item is a sunglasses holder for a sun visor. And it is...
And it is...
We think...
Haven't got an
A
answer.
sunglasses holder. And the reason why, guys, is because... Victor, we're always asking for different objects, aren't we? And for the first time ever, Victor G3JMB says, I found this thing on my living room floor, but I don't know what it is. So could you possibly use it as a picture in your competition? And then I might be able to find out what it is. So the only real problem with this, of course, is that most people have said it's a sunglasses holder. So we think it is that. We hope it's helped you as well, Victor, solve this mystery about what you've had lying around your living room for a couple of years, apparently. But we thought it was a nice twist on the competition anyway. So thanks very much for sending it to us, Victor. I hope it solved the problem. Maybe look online to find out exactly how you fit your sunglasses. I think that bit, those clip bits,
I think you push the end piece and it actually opens and you put the nose piece between them. I have seen one before.
Do you think, thanks, Tammy.
clip-
Do you think we're now going to get a rush of people sending us things they don't know what they're for?
Probably.
And seeing what they are. Anyway, thank you very much for sending that, Victor. Thanks to all of you who entered. We've got something really different for you now when we ask you, what on earth is this?
And we actually do know what this is.
Well, only because they told us.
I know, but I mean, it's not a random mystery item.
I see. No, this is a genuine thing. We do know what this is. But do you? You have got 2 weeks to let us know by 3 o'clock to Wednesday week.
3 weeks.
3 weeks, is it? Yes, you're right, 3
tabletop
weeks. Yes,
sale.
we have. We've got an extra week in there. So it's 3 weeks you've got to work out what this is. If you know what it is, though, let us know now. Drop us an email to radio@dcpmicro.com and we'll tell you who's right and who's wrong at the end of it. It's a kind of everyday object, I suppose, depending on what you do. I better not say any more. You always tell me off when I give any clues or anything. Anyway, we're nearly up to our main event tonight and meet our guest. Firstly, though, just to tell you what's happening this week at the club. So on Sunday, we've got the GB Tourist News on GB3MB. On Monday night, the Monday Night Net on GB3MB at 7:30. And at 8 o'clock, the 80-metre CW Net on 3.543 megahertz. And then next Wednesday, as I mentioned, that's January the 31st, we've got a meeting at CNS, which is a social, Bright Sparks and Raspberry Pi. If you're interested in any of those things, that's next Wednesday. And then it's the following Wednesday when we have the tabletop sale and an auction as well. So start looking around, finding those things that your wife might be getting ready to sell without you knowing. And watch it, the things there. And hopefully you'll join us for that. And don't forget to keep sending us your stories, your pictures, and your mystery objects as well. And of course there's our club card, which we're very happy to send to anybody you feel will be cheered by receiving a club card. Just send us their name and address, we'll add your name to ours, and we'll be happy to post it to anybody at all. They don't have to be members, don't have to be radio amateurs. It just might cheer people up. So now it's time to meet our guest tonight for our main event. Now, in October 2023, it didn't hit much news here, but there was a solar eclipse in America. And someone who was really interested in the effects that this might or might not have had on propagation was Gwyn G3ZIL, and is with us now. Hello, Gwyn.
Hello, David. Hello, all.
Lovely to see you. Thank you very much for joining us. We have actually met before, haven't we? Because anybody who was watched the convention, the live stream from the RSGB convention last year, you were sort of tagged on as a late item one afternoon on the Saturday, I think, to tell us about this research. So it's really good to see you and to find out what the results are, because it was that weekend, wasn't it, that this was happening?
It was indeed. It was really excellent timing. It was the Saturday of the RSGB convention, and at about 5 o'clock UTC, so 5 o'clock our time, the eclipse was just starting over the West Coast, Oregon, Washington State, California. And I was very hopeful that what I was pointing out to you during that live interview was actually some of the features of the eclipse, and thank goodness they were. And this talk really follows on from that short conversation.
Absolutely. Well, we'll leave it to you, Gwyn. But as always, this is live, and so if you're watching it on Wednesday, this is live, and you can ask questions and make comments, and we'll read them to Gwyn at the end. But over to you, Gwyn, for the presentation.
Okay. Thank you very much, David. Well, good evening, all. It's my great pleasure to give this talk on some of the effects on HF propagation of the 14th of October 2023 eclipse over North America. And I'm grateful to Roger and NARC for giving me the opportunity to present tonight. And along the way, I'll introduce you to FST4W. Now, that's such a mouthful. But it's a whisper-like beacon mode within the well-known WSJTX software suite. So the topic of the eclipse, Steve Nichols, a NARC club member, wrote an article in Radcom in 2015 about the several effects on propagation of the April 2015 eclipse that was visible over the UK and did affect radio communications in our part of the world. And Steve highlighted the use of new technologies that were then available over the 16 years since the 1999 solar eclipse over the UK. And it's one of my aims tonight to show that the pace of innovation in technologies and methods for amateurs to study propagation at HF has not slackened even since 2015. So the outline of the talk for tonight. I'm going to say a little bit about my background and my very early steps with Whisper. And I hope that by returning to my very own early days with Whisper, I'll be retracing my steps, some of them faltering. And in that way, I hope to carry you with me into perhaps unfamiliar territory. The FST4W mode for one, and for another, perhaps the graphical ways of looking at measurements and effects on propagation. I'll try and communicate to you. And I'll end with an idea for how UK amateurs might contribute to studies of the 8th of April 2024 total eclipse over North America, but I think we may see some effects from UK as well. So I was licensed in 1970 as GW3ZIL on the island of Anglesey. SH28 is still burnt into my memory. I was 15, and at school, I was really intrigued by radio transmissions that I could hear at the very top end of the medium wave band on a 1950s domestic Pi set, my mother and father. And what I was intrigued by, really the call sign Charlie George, oh, that's how I remember it, Charlie George for Coast Guard, transmissions from the Holyhead Coast Guard. And obviously, most fittingly, one of those Coast Guards, the late Paul Lane, GW3MQX, helped me become GW3ZIL. But perhaps because of living so close to the sea, my curiosity extended to using wireless underwater. So I'm the whole person on the left in this picture. My school friend Robert Keane is in the wetsuit, as he was a keen diver, he'd made the wetsuit himself, and attached to the top and down at his foot were a pair of electrodes. And then he had a throat microphone, and coupled to some electronics that we'd built as what I now call a baseband audio transmitter. He'd be underwater and I'd be on the surface with a pair of electrodes on Holyhead Beach, listening to Robert while he was exploring a few meters below the sea surface. And so this is all under the guidance of an incredibly tolerant and supportive physics teacher. And this is really, I guess, in the era before the STEM acronym was invented. But again, the formative influence of teachers were incredibly important throughout my life, really. And my interest in equipment of that era that I had, the KW Viceroy and the KW Atlanta, continues. And I have a little site at radiomuseum.org. So it was the ocean side that really founded my career rather than radio in the ionosphere. And I had a fulfilling career for 40 years as an electronics engineer to start with, supporting equipment at sea and developing new instruments. So I could describe this sonar as a fixed frequency, 1 megahertz, direct conversion receiver with quadrature outputs to an analog to digital converter with digital signal processing on an RCA 1802 microprocessor to extract signal level and Doppler shift in 2-meter long range intervals away from the instrument. It's a 1987 software-defined radio. But it does help that underwater sound only travels at 1,500 meters per second, so you get an awful lot of Doppler shift. Then later, the last 20 years of my career, I was a group head in oceanography, and our major effort was designing and building autonomous underwater vehicles. They can go where ships find it difficult, such as under ice. Here I am off northeast Greenland at about 80 degrees north, or indeed impossible situations. You can send one of these robot submarines under 500 meters thick ice over floating Antarctic glaciers and ice shelves. And we did that for hundreds of kilometers. And this vehicle is the precursor of something you may have heard about every now and then, but Boaty McBoatface. But to return to amateur radio, and after my retirement, it was absolutely a brilliant hobby and really the amateur radio service to return to. And what sort of fitted my interests emerged as Whisper on the HF bands, where I could return to the direct conversion receiver designs of my early days as an engineer. And I was inspired by Gene Marcus, W3PM, his design, and laid out on a PCB, so learning the use of PCB tools and how to have them made for you in China, with a crystal oscillator and a single crystal front end. So the very first thing was after the tuned circuit was a crystal that passed the USB, and you had these trim capacitors here so that you could put a null from that crystal frequency at the LSB site for your image rejection. And I had that published in Practical Wireless in April 2016. And then I went on to a project that, while interesting and taught me a lot about how to code with Arduino and synthesize a Whisper output, as a Whisper transceiver, it was really quite a failure. But but my implementation was far too noisy. So, nice circuit ideas, but the practical implementation on reducing noise, I didn't do a good enough job. But what that did lead me to do was to understand a little bit more about noise in circuitry as one is building that, but also to explore noise cancellation for noise that was coming in via the antenna. And this led me to looking at the well-known technique of noise cancellation using a pair of antennas and altering the phase of one and matching the amplitude of the two sets to achieve 180 degrees phase shift and the cancellation of the noise, whichever direction a single noise source was coming from. And my prototype here was intended for use with Whisper on one band and 40 meters in this case. So in this case, I had two dipoles, switched attenuator from 1 to 7 dB, and in the other side, a switch delay line to give the phase shift, using RG174 cable, all bundled up here, different lengths in the small box, to give roughly 3 nanoseconds phase steps up to 80 nanoseconds, which gives more than enough for 0 to 180 degrees phase shift on 40 meters. The two signals are combined and fed into a receiver whose audio output is processed by Whisper in WSJTX as usual. But then an innovation was that within the 8-second gap at the end of a Whisper transmission, the fully automated software would go through the attenuator and delay settings to find the minimum noise and apply those settings for the next cycle and then log them so that I could see the benefit. And this graph here on the bottom right is one of the most impressive noise reduction examples that I was able to achieve. About 18 dB improvement in signal to noise ratio. So as one goes along this axis of the graph, which is delay, you suddenly get a small improvement and then a large improvement. And it's quite a sharp notch in delay that gives you the best SNR. And on this axis, the green line shows you how you get a dip by choosing the right attenuator settings to get the best overall. And so that was a neat project on noise measurement. So how on earth did I get involved with the American 2023 Eclipse? Well, it all started in a coffee shop in Sonoma County, Northern California, just across the Golden Gate Bridge from San Francisco. Not that I've ever been there, but my interest in noise measurement and noise reduction had led to many enjoyable and productive email exchanges with Glenn Elmore, N6GN. He and many of these good folk met each week at Coffee Cats, Sebastopol, Sonoma County. And they welcomed my participation over the internet as if we had known each other for decades. So I felt this was really quite a touching example of the true international spirit of amateur radio. And this group's interests included installing and maintaining multiple Kiwi SDRs, software-defined radios, at the nicely restored Maritime Radio Receiving Station KPH. And it also led to a substantial software development by Rob Robinett, AI6VN, Whisper Daemon. And Whisper Daemon is a very robust decoding and reporting system for Whisper, for Kiwi SDRs, and now RX888 and other multi-channel receivers. And I was able to contribute my noise measurement work into Whisper Daemon with Rob. And Whisper Daemon accepts many more variables than does whispernet.org. And that's been crucial to some of the studies that I'll share with you today. So the 14th of October 2023 annular eclipse over the US. So annular, it's not a total eclipse. The moon's position was such that it wasn't large enough to cover the entirety of the sun, so that there was what's known as a ring of fire around the sun at maximum. But even so, some 95% of the sun was covered along the track during this eclipse. And this was a coordinated study by HAMSCI. HAMSCI is the Ham Radio Citizen Science Investigation, led and inspired by an ionospheric physicist, Assistant Professor Nathaniel Frizzell, W2NAF, out of the University of Scranton, Pennsylvania. And HAMSCI is a platform to promote projects that brings the amateur community into contact with professional scientists and engineers studying the ionosphere. And it really does so to the benefit of both sides. It's not one-way learning, it really is both ways. And of their many activities, it is the HAMSCI Festival of Eclipse Ionospheric Science that is central to this talk. We looked at using WHISPER, given our deep interest, and how it gave interesting results for the 2017 eclipse over the US. And indeed, as reported by Steve in his Radcom article, WHISPER did give some effective results for the eclipse over the UK back in 2015. But could we do a little bit more? We wanted to move beyond what had been done before. Now, over the last few years, we'd come to realize that signal-to-noise ratio, SNR, is not the only factor that affects the probability of decoding a WHISPER signal. Frequency spread has a big effect on this very narrow band mode. So here's a graph from Steve Franke, K9AN, the F in FT8 alongside the T for Joe Taylor. And this graph, I think, deserves to be better known. So on the x-axis, we have the signal-to-noise ratio expressed in dB, in a 2.5 kilohertz bandwidth. And WHISPER users may very well see the occasional minus 32 dB. So let me put my cursor at minus 32, and that's about when you have a probability of decoding a signal of about a half. But what this graph shows is that your decoding probability is only a half if the Doppler spread, the frequency spread associated with that reception, is 0.01 hertz, 10 millihertz. If you've got more Doppler spread on that signal, then the probability of decoding of 50% now requires minus 29 dB. If you've got 2 hertz Doppler shift, you now need minus 26 dB, and 2.5, you're going to need something like minus 16 dB to have a 50% chance of decoding. So frequency spread is important, as SNR is, to the probability of decoding a WHISPER signal. Now, Steve Franke labeled this graph Doppler spread, but I'm going to use throughout this talk the wider term frequency spread, as it's not only the ionosphere that is spreading the frequency through jittery Doppler shifts as it comes on, to the receiver. Jitter or phase noise in the transmitter itself and receiver also add to this graph. So if you've got an oscillator in your receiver with a lot of jitter, you might already be up into this region. Never mind what the ionosphere is doing to your signal. And I'll also make the technical point that there are various ways of measuring frequency or Doppler spread. For instance, between the upper and lower minus 10 dB points on a signal spectrum. For technical accuracy, what I'm going to use tonight is W50, the width spanning 50% of the total power. That is between minus 3 dB of the signal spectrum. So we know it's important, but how do we go about measuring frequency spread? Well, the answer, surprisingly, was quite easily. But it was pretty well hidden at the same time. Introduced in the 2.3 release of WSJTX back in 2021 was a new mode, a beacon-like mode, FST4W, very much like Whisper, but it can measure frequency spread. But turning on that option is really one of the most curious ways of setting an option I've ever come across. So you have to put an empty file called plotspec into the directory in which WSJTX is started. And that'll give you frequency spread. Now, we've made detailed studies of equipment frequency jitter, and you'll find reports on the Whisper Daemon website down here. But more importantly, John Siemens at QESDR and Hans Summers at QRP Labs have made significant improvements to reduce the frequency jitter, the phase noise of their products, such as the QDX and the QCX, arising out of these findings. And identifying frequency spread of different propagation modes is the subject of my RSGB Tonight at 8 talk on the 5th of February. Now, we can clearly identify different propagation modes from their SNR and frequency spread. And we thought this would be useful during an eclipse. And we weren't wrong, but there are several challenges. WSJTX is suboptimum for receiving FST4W. It only deals with one length at a time of the many lengths that you can have. But Whisper Daemon has now been modified by Rob Robiner to simultaneously handle all lengths and report frequency spread to its own database. There is no drift compensation in FST4W, unlike Whisper. And so there are these tighter equipment spreads. And it really is best to use an analog TCXO or a GPSDO at transmitter and receiver. An ionospheric Doppler spread means that it's the 120-second long variant, the same length as Whisper too, that is actually useful. But there's still very few people transmitting and receiving. So this is all part of a publicity effort to try and improve awareness of this mode. So what equipment can you use? Well, at the high end, software-defined transceivers with external phase-locked GPS-disciplined oscillators do meet the requirements, such as the Anon from Apache there, the 100D. But so too can lower cost equipment, including kits. So the QDX from QRP Labs, for instance, is usable, and it's even better if it's clocked by a low-cost GPSDO, such as the Mini Bodnar for Bodnar Electronics. Now, the 60-pound RF0 module transmitter comes with a GPS-aided oscillator that really is very good indeed. It's almost as good as a phase-locked GPSDO for this application. Here I've added a relay-switched low-pass filter board from QRP Labs and a QRP Labs linear amplifier to boost the 20-watt output from the RF0 itself. So there's kits you can build, you can get on the air with FST4W quite easily. But it's also spurred innovation. Here, Paul Elliott, WB6CXC, designed the Whisper Sonde specifically for the Eclipse. It can transmit simultaneously on 6 bands and at 100% duty cycle, and with a phase-locked GPS-disciplined oscillator stability. Now, clearly, under normal conditions, this would be frowned upon. But as changes in the ionosphere happen quickly during an eclipse, A transmission every 10 minutes with a 50% chance of being decoded is not going to describe the response of the ionosphere very well. 5 whisper swans were deployed for the 2023 October eclipse, and they've produced excellent data, as we'll see. So here's a map showing the track of the annular eclipse on the 14th of October. So it's in cyan here, from offshore Oregon in the northwest, across Utah, Texas, into the Gulf of Mexico, and then going over Costa Rica before petering out. Now, what I'm showing on the map as map pins in red are the transmitters for FST4W, and the receivers, mostly Kiwi SDRs or RX888 multiband sets. And then with the whisper sons are WS, they're marked WS here. Washington State, California, Nevada, and Missouri. And here, John Clark, TI4JWC in Costa Rica. And I'll be showing results tonight for a selection of transmitter-receiver paths. So along the eclipse, across the path of the eclipse, and at different frequencies to bring out a variety of effects that we've been able to observe and measure. So let's start with some real results. Now, we were not able to cover the medium wave or 160 meters, where many useful reports of increased signal levels were reported for the 2015 eclipse over the UK in Steve's Radcom article. But we were able to see and quantify increased signal levels from reduced D-layer absorption on 80 meters. Here is just one example. So this is on a 466 kilometer path from northern Utah to Nevada across the path of the eclipse. I've taken the signal to noise ratio of the FST4W spots and Whisper Demon's noise level measurements from Tom Bunch, his receiver W07I, to calculate signal level here now in dBm on the y-axis, and most of my graphs are going to have time of day on the x-axis. And I've marked the start, middle, and end of the eclipse on this with the blue vertical lines. Now, let's compare with the same time on a non-eclipse day. So it just happened that at this time of day, this time is all UTC, so we subtract 7 or 8 hours for the local time. So this is morning, 80 meters is closing on a normal day, and the signal level is reducing. But what happens on the eclipse? But interestingly, not as the eclipse starts to affect the center of this path, but will on, but before the maximum, the signal level starts to rise. It reaches a peak, and that peak is about 12 to 15 dB above the level on usual non-eclipse days. Remains there for about 40 minutes and then decreases quickly, and as the band closes, we lose the signal before the end of the eclipse itself. So we were fortunate that 80 meters remained open at the time of the eclipse here. But there's a clear increase in signal level. And this was using a whisper sonde, so we have measurements every 2 minutes to see the very nice shape of this increase. So it's not just a narrative, we can measure it in dB. So the other effect on an eclipse, as well as the shadow reducing the absorption in the D region, is that reduced ionization, as the sun has been switched off, so to speak, for a brief period, is that it lowers the critical frequency. So it lowers the maximum usable frequency. Let's have a look at that, in this case, on 10 meters. Now, we've got John Clark here, TI4JWC. He's operating a whisper sonde, and his Costa Rica location is right at the edge of the annular path. And I'm now going to look at spots of his transmissions that were received in Nevada at ND7M, Dennis, and also at the Northern Utah SDR site, KA7OEI-1, and then at 2 coastal stations in Northern California, KFS and KPH. So I'm using the most simple of measurements here. So we've got time of day, again, on the x-axis. And on the upper graph here, I've got circuit reliability. So this is the number of spots in a 20-minute interval that were received, expressed as a percentage. So if we received all 10 spots in 20 minutes, it'd be 100%. If we received 1, it would be 10%. So what we see is that KPH and KFS, at a range of about 5,000 kilometers, do show an effect. There's a dip in the middle there, quite clearly. So what in this bottom graph I'm plotting on the y-axis is distance from John in Costa Rica. So in green is Dennis, ND7M, and in orange is the Northern Utah SDR site. Now, in contrast to California, they have really quite long gaps, about an hour's gap, and a bit less than that here happens again. And in the middle, the signals have come back. So what's going on here? Well, what I think is happening is that the eclipse had an effect on one hop on this 2-hop path, and then it had an effect on the other hop. So, and I'm going to put in a little sticker here that I'm going to return to this at the very end, and the April 2024 eclipse and the opportunity for UK amateurs. So how can we see if that idea about affecting one hop and then the second might have any basis in fact? Well, we can do that using ray tracing. So ray tracing is a useful propagation modeling technique that can help our thinking about what was happening during the eclipse on those 4,300 to 5,000 kilometer paths from TI4JWC, Costa Rica. Now here I'm using the PyLab ray tracing package. This is freely available from HamSci via this GitHub link. I've specified the date, the time, the frequency, and the initial starting latitude and longitude in Costa Rica, and the bearing from John towards those stations. And then, crucially, what we have here called R12. R12 is the effective sunspot number, the 12-month running average. Now, I don't have that yet for October last year, so I use the effective sunspot number from a website from Northwest Research Associates, who publish an effective sunspot number that can be useful for experiments like this in ray tracing. So here on the very left, we have John TI4JWC. And this graph goes in altitude from 0 up to 400 kilometers. And the color scale here shows the frequency, if you like, the plasma frequency related to the critical frequency of the F2 layer. And the white lines are individual rays from 2 degrees up to 40 degrees. So the steeper rays just escape through the ionosphere. And here we have refraction, and we have the first hop. The first hop takes us to nearly 2,000 kilometers at the high angle, and the first hop takes us to about just over 3,000 kilometers for the low angle rays. And so then we have the second hop that takes us to about 3,700 kilometers all the way to 5,500. So all of the stations that we've looked at from Nevada, Utah, California, were receiving the second hop. And this is on a non-eclipse day or before or after the eclipse. But what happens now if the critical frequency has been reduced? The ionization has been reduced because the sun has been blocked by the eclipse. So what I can do is to artificially lower the R12, the sunspot number, to a value that I find by trial and error that's low enough that pushes the second hop beyond Nevada. So now we have a gap. ND7M is in the skip zone for the second hop. He's not receiving the transmissions. But you'll see here that at 5,000 kilometers or so, KFS and KFPH are still within the zone of the landing spots of these rays. So it mostly continues at KFS, KPH, but does not at MD7M. So what's happened is that the eclipse seems to have dropped the sunspot number to about 70 from its value for that day, undisturbed, of 125. So that's an interesting finding. So another effect of the lower F2 critical frequency can be seen on 20 meters and on 15 meters. So I'm showing circuit reliability again in the top graph with the deep blue as 21 megahertz, 15 meters, and in the sort of cyan, 20 meters, 14 megahertz. And the critical frequency dropped on this 1,566 kilometer path all the way from about 50% reliability down to 0 during the eclipse on 15 meters, but remained up on 20 meters. But there was an effect on 20 meters. The signal level, the SNR, did drop between the maximum of the eclipse and the end of the eclipse. It did not stay high. There was an effect on SNR, but the circuit reliability stayed up. But there was a complete absence of spots, a clear gap on 15 meters from just prior to the maximum of the eclipse until its end. But what on earth happened here on 20 meters after the eclipse? It went to 0. So I guess this was a clear lesson that we might think that we start to get to grips with some ideas and thoughts on propagation. But there are always effects that then seem to stymie us. So what might have been going on? Ray tracing again can be useful. So on the left is 15 meters. The top trace is with the sunspot number of 125, which is the undisturbed value on a non-eclipse day. And we see that one hop enables us to go on this path from WB6CXC, Sonoma County, Northern California, to Glen Elmore N6GN in Northern Colorado. So he is within the reception zone here for one hop. But now we drop the sunspot number down to 70, which we found was the value from the Costa Rica experiment. And we see that N6GN is now just on the edge of the skip zone. So that's clearly lines up nicely. So the value of sunspot number dropping to 70 that we saw on the long path from Costa Rica to Northern California is also applicable on the shorter 1,566 kilometer path from California to Colorado. But what was happening on 20 meters? Well, a possible explanation is that NCXGN was just too distant for one hop on 20 meters, but not far enough for two hops. Now, the ray tracing is a little bit equivocal here, but you can see that he's certainly not in the main area for two hop and not in the main area for one hop reception. He is sort of between the two. This is also a reminder that with ray tracing, it's never an exact simulation. It's not like a weather forecast for a particular day. It's more to do with climate. But that is really a bit of a hand-waving solution to that particular conundrum. So what other forms of changes to propagation can we see using our measurements? So what do we see now on this path? Now it's 1,808 kilometer path from Dick, W7WKR in Washington State, to Dan, KV6X in New Mexico. And this is on 20 meters. Now, all three of these graphs have a common time axis. The top graph is circuit reliability again, in 20 minutes, as we've seen before. The middle one is signal level. And the bottom graph is now frequency spread. So this is the additional measurement that we can make because we were using FST4W. Now, the normal propagation during a day is for this path to start off being one hop. And we can see that really because of the experience we've gained in interpreting frequency spread, that for one hop, frequency spread is low, under 100 millihertz. And I've clustered those here with in an oval labeled A. So as the band opens, the frequency spread is generally low on most days. And we've got one red square in there, which is the Eclipse day, 14th of October. But very soon after the band opens, one hop and two hop can take place on this 1,808 kilometer path. And when that happens, the frequency spread is no longer less than 100 millihertz. It really becomes quite variable, and from 100 millihertz up to 300 millihertz, it's all over the place in this region. And that's an indicator to us that we've got one hop and two hop propagating at the same time. But what happens during the eclipse? And so I've drawn this blue line at the center of the eclipse. What's happened is that the circuit reliability has dropped, as we've seen before. The signal level has dropped, again, as we've seen before. But now what we have is additional information from FST4W that the frequency spread has dropped. And it's really only on those days, on the eclipse day, that we have these low values circled as B. So what's happened here is that the lower critical frequency on the eclipse day has reduced the ionization such that two hops cannot be supported any longer, and the path has reverted to one hop. And we know that because the frequency spread is low, it's comparable to one hop that we see as the band opens at the start of the day. And we would not have been able to make that deduction from looking at circuit reliability or signal level. So it's the frequency spread that's told us that two hop becomes one hop. So what happens to one hop? Well, one hop becomes a mode that deserves to be better known, two hop side scatter. Now we're looking at a shorter path, 1,055 kilometers, also from Dick W7WKR in Washington State, but this time to KPH, Northern California, across the path of the eclipse. Now this path is short enough for only one hop propagation to be seen on normal days. So in the top graph, again, I've got time on the x-axis, and I've got signal level on the left y-axis, and signal level are the cyan dots. And then I've got a secondary y-axis here on the right-hand side, and this is now frequency spread in millihertz, and I'm plotting that data as orange dots. So you can see that the orange dots read on this secondary Y scale on the right-hand side, they're virtually all normally under 100 millihertz. So this is consistent with us saying that this is one hop propagation. But then after the time, excuse me, around the time of the maximum eclipse and then intermittently afterwards, we have what look like outliers, both in signal level and in frequency spread. But they're not really outliers, they're not measurement errors, they're telling us something about a change of propagation mode. Now we can interpret this as follows. So on this graph on the bottom left, I have signal level on the x-axis in dBm and frequency spread on the y-axis. And then this is a scatter plot. So I plot a dot for every combined value of signal level and frequency spread. And then I add contours. So you interpret this like you would on a map with contours, that most values occur here within the central area and at the peak, if you like, of this mountain of spots. And that's one hop. But during the eclipse, we have values that wander off here. So they go off towards weaker signals and greater frequency spread. Now, what's important to realize is that this isn't just a weaker form of one hop. It's a completely different propagation mode. So here we have a map. And the black dot is the transmitter location in Washington State. And we have KPH as the blue dot on the Northern California coast. When one hop is in place through most of this interval, then the skip zone from the black dot transmitter is sort of along this white curve here. So KPH is receiving one hop. During the eclipse, the ionization has dropped and the skip zone gets pushed out to well over the Pacific Ocean. So it's now beyond KPH. So KPH does not receive one hop signals. But one hop still happens. For instance, one hop can take you out over the Nevada desert, out here. And that signal, by forward scatter, the normal mode along a great circle line, would go off here towards Texas, for instance. But the signal isn't all in the forward scattered mode. Some of it is scattered at all angles, and some of it will be scattered such that it ends up at the receiver of KPH. So we have two hop side scatter, one hop up here to the ionosphere, back to the Nevada desert, then scattered off the Nevada desert, back up to the ionosphere by one hop, and back to KPH. So that form of propagation, two hop side scatter, is what happened after the eclipse went over this site. And there's more on that on my RSGB talk. Now, to change tack, we can measure precise frequency, given that we have GPSDOs, or at least GPS-aided receivers and transmitter. And why do we want to measure precise frequency? It's because we can then track the change in height at which signals refract in the ionosphere as a response to the eclipse. Now here we have ionosonde data, which appears fairly now and then in articles in Radcom, from the Point Arguello ionosonde at the Vandenberg Air Force Base, California. And what I'm particularly interested in is this curve, this thin black line that then becomes a dotted line, the level of ionization and the peak height of that ionization here, about 320 or so kilometers. In fact, 334, I see that, 334 kilometers. And as a cartoon, really, I've drawn a transmitter with a path up to the ionosphere and then refracting at that height at the peak of that black curve and coming back to the receiver. And then an hour later, the black curve has descended so that it's at this height, it's at 284 kilometers, and now the transmitter sends the signal, refracted at 284, arrives at the receiver. So this path here, transmit, receive at 1300, is longer than the path for our signal at 1400. Now, using some simple geometry, we can then work out the change in ionospheric height. And we do that because we measure the Doppler shift of the signals. And here's a Whisper Sonde 6 at Tom, W07I, to Dennis, ND7M again, on this 545 kilometer path in Nevada. And the dark red spots are from 80 meters, the orange from 40, and the cyan from 30 meters. The Doppler shift in hertz from these well-known transmit frequencies. And we see it first on 80 meters. 80 meters has been open all night. And the Doppler shift gets larger and larger. So as the ionosphere descent starts to accelerate and reaches a maximum speed and then starts to slow down. So we see that entirely on 80 meters. And then 40 meters opens. So we don't see the start of the descent on 40, but we see it here in its Doppler shift. And then a little later, 30 meters open, and we still see some Doppler shift from the descending ionosphere at 30 meters. And it's a good thing that they don't overlie, because the magnitude of the Doppler shift is proportional to frequency if the rate of change of path length is constant. So this is exactly what we'd expect, greater Doppler shift at the higher frequencies. Now we can remove that dependence on frequency by plotting now the rate of change of path length. So the velocity of light times the Doppler shift divided by the frequency gives us the path velocity. How many meters per second the path length overall is changing. And now when we do that, we see that the measurements at the three frequencies do line up, which is excellent. But then something odd happens at 80 meters. We get zero Doppler. It doesn't agree with the other two. So what I think has happened there is that there's the always there E-layer refraction is happening. And 80 meter refraction is now only from the E-layer, not from the F2 layer. And the E-layer isn't moving, the F2 layer is moving. And that's what's refracting signals at 40 and 30 meters. So we can take this measurement of path velocity and convert it into height of the ionosphere. Now, Doppler shift tells us about the rate of change of path length, but tells us nothing about the actual path length. So what I've done is to calculate an estimate of the path length from a height of the F2 layer from the ionosonde just once. In fact, at 1500 UTC, when its height was 230 kilometers. And then I calculate the path length using this geometrical equation as 721 kilometers. And at that time, the Doppler shift on 40 meters was 0.3 hertz, minus 6.7 meters per second. Now we have a measurement every 120 seconds, the 2 minutes of our whisper interval or FST4W interval. So then we can calculate the path length, just 120 seconds times 6.7 meters per second, which gives us, and in fact, taking the sign into account, minus 0.8 kilometers. So we know how the change in the path length. And knowing the change in the path length, we can then calculate the height of the ionosphere. And when we bring that together, we can, from the 1500 UTC, when I've just got to use the ionoson data once, I can calculate backwards to height of the ionosphere at our different frequencies. So the 80-meter height here in the sort of orangey red, and from the other frequencies, they track really well as those bands have opened in the morning. And then going forward in time from 1500, I can calculate the height of the ionosphere as it's changed on 40 and 30 meters. And the ionoson gives us two measurements of height, the minimum virtual height, which is in black, and the peak height, which is in gray. And our measurements lie between those two, which is good. They don't deviate outside those boundaries of the two different heights measured by the ionosphere. And so somewhere in here, between start and end, there is an effect on the height of the ionosphere from the eclipse. Well, what we can do is to look at the height of the ionosphere on the following day, undisturbed. And that's what I've done in this graph. So in the top panel, in magenta, is the height calculated exactly as I did during the eclipse day, but this is not influenced by the eclipse. So you can see it's a smooth change through this region. And so this bump in ionospheric height that we saw is due to the eclipse. And when I plot the difference, just taking the difference between the magenta and the average of the cyan and orange plots, we now have a measure of the change in height of the ionosphere during the eclipse. And here it is. Now this change does start when the eclipse starts, ramps up, reaches a maximum just after the maximum, and comes down. So here is additional information on the height of the refraction at these two frequencies of the ionosphere that we've obtained from what may seem like very simple measurements on an FST4W spot. And having mentioned Steve Franke for the F in FT8 and so on, and Joe Taylor for the T, it's only fitting as I draw to a close to acknowledge the S in FST4W, the late Bill Somerville, G4WJS. So what about a role for UK amateurs in the April 2024 eclipse? It ends at sunset in the mid-Atlantic, but when we look at a ray trace model, as we've done, much like the path from Costa Rica, then here we have the second and the third hops on 15 meters, 21 megahertz, are in the region affected by the eclipse, very much so. So this is just a model, and the sunspot number here, I've just used 100. But I think it's very worthwhile trying Whisper on 21, 24, and 28 megahertz from 1700 to 2100 UTC on the day before, the day of the eclipse, the 8th, and the day after, the 9th, and to see if we can see the same sorts of effects that I saw from Costa Rica to California on the path from the UK to North America, where there are some really good Whisper reception stations very close to the path of the eclipse. That would be an interesting experiment. So to summarize, it's been a true delight to return to amateur radio after a long absence and to be able to find, mold, and create a field of interest. It's such a diverse world, amateur radio. And the digital modes within WSJTX can provide so much more information than basic automated reports of SNR. And eclipses provide a natural experiment for us to study firsthand propagation modes that we've learned about in books, and sometimes ones that are really actually hard to find in books, like Two Hop Side Scatter. So join in, any time is a good time, and bookmark the 8th of April 2024 eclipse. And to acknowledge many thanks to the WSJTX development team, Rob Robinette for Whisper Demon and its amazing logging and database, the KPH KFS installations, and all of the amateurs that it's been my delight and pleasure to work with on this data. Thank you.
Thank you very much, Gwyn. Well, there's a lot to pack in here, and I'm sure that people at home have got some questions or comments to make. So if you have, please ask them now, either on Facebook or on BATC. Obviously, the next eclipse, I guess it was. Sorry, but first thing I wanted to ask you was this the first time this research has been done, as far as you're aware, in an eclipse?
The Nathaniel Frizzell and Hamsai had done a lot of work on 2017 eclipse, but they concentrated on, if you like, the mass data gathering of spots. So how many spots were received across the USA, rather than looking at individual paths in detail and being very careful about the quality of the signals, the frequency stability and so on of them. So this is a first, as far as I'm aware, in this sort of path by path detail.
And so I guess the next one coming up in April is going to be really important, because that gives you a second set of data to do comparisons with. Would that be right?
Absolutely. And, several of the people I've mentioned here are going to be installing the Whisper songs, multi-frequency simultaneous transmissions at different locations, and also going portable as well into the path of totality.
Yeah, and you said and invited radio amateurs to take part in this. If they really want to do it in a serious way to provide data, how would they best work with you for this?
I think that we can now measure frequency spread experimentally on whisper transmissions. So you needn't use FST4W. Whisper is fine. I have a feeling that transmissions from the UK being received at low noise sites in North America might give the best return. But that's not to say that there are some excellent low noise sites in the UK that could hear the reverse, transmissions from the US that will be made purposefully on multiple bands simultaneously. So the message is that if you're using Whisper, especially transmissions, and to try 15 meters and above during the time of the eclipse, as that's what would give us the second and third hops within the path of the eclipse. So that's the message, and to do so on the day before, the day of the eclipse, and afterwards.
Okay. Now, most scientists, when they do something, at least sometimes they have an idea of what might happen, and sometimes, as they call it, a significant unknown. So your first set of data that you just received in the October 23 one, were the results pretty much as you expected them to be, based on your research before?
In general, yes, in that I was able to see effects of reduced D-region absorption in the increased signal levels on the lower bands, and that we were to see effects of reduced MUF on the higher bands. So if you like, those big picture messages and expectations were met. But what we now have are detailed numerical values for those disturbances. That an estimate that it was equivalent to the sunspot number dropping from 125 to 70. that propagation modes changed. It wasn't just one hop but weaker, it changed to 2-hop side scatter. It wasn't just 2-hop but weaker, it changed to 1-hop. So we have those detailed nuances that we didn't have before.
Yeah, so maybe the effect was similar, but you couldn't quantify it. Would that be a fair way of putting it?
Yes.
Okay. Well, we haven't really got any questions for you. I don't know if that means that people are baffled or they're going away to think about it, and hopefully there will be people who will help with this research in April. Jim G3YLA, who I'm sure you know, has said, a wonderful presentation, Gwyn. Welcome back to amateur radio, and hope the slides will be available afterwards. I don't know if you're prepared to share them. You don't have to put them publicly, but maybe if you're happy for me to share them with anybody who asks.
I on the Whisper Demon technical, either technical or presentations, I look after the Whisper Demon website, and they will be available there, as will be my speaking notes.
Lovely. Okay, I'll let Jim know that, and everybody else as well. And of course, we're looking forward to, and it will be us again hosting tonight at 8 for the RSGB on the 5th of February, when you're going to go into more detail. Can you just tell us again the difference with that talk over this one, the key differences?
So I mean, there'll be an introduction a bit like this one, but with completely different slides, but the introduction story will be there. And then the second, the main part, the main technical part of that is to do a deep dive into this 2-hop side scatter mode, and how did I get to appreciate that that's what was happening? How did I start to learn to interpret frequency spread and associate it with different propagation modes? And I'll be looking at experiments. There'll be some animations on how the region of the 2-hop side scatter can vary throughout the day. And does that make sense? And how we're able to verify the location of that scatter by what I called a rotating antenna experiment. So my collaborator in the US with a 5-element 20-meter beam was able to direct his beam towards the sea, towards the Pacific, and we could see that that's where the strongest signal came from. It did not come via the Great Circle path during 2-hop side scatter. So there's some experimentation and there's some animations on this underappreciated mode.
Well, we look forward to seeing you again in early February for that. And of course, presumably after the eclipse of April, then you'll be doing lots more work and number crunching, and then maybe you'll come back and see us again and tell us what that tells you now, comparing the two effects. Yeah. Gwyn, thank you very much for this evening's talk. We're really grateful for you sharing this data and everything with us, and we hope that other people will also join us. Some of the viewers from here will also join us from tonight at 8 in a few weeks' time. But until then, thank you very much to Gwyn. Thank you, Jim.
Right. Cheerio. Bye-bye.
Thank you. And there we are. That was Gwyn, G3ZIL. We're really grateful for him to coming to give us such a wonderful, detailed presentation. That's almost it for NARC Live now. Just to remind you again what's coming up this week on NARC. On Sunday, the GB2RS News on GB3NB at 7 o'clock. 7:30 on Monday night, it's the Monday Night Net on GB3NB as well. And at 8 o'clock, the 80-metre CW net on 3.543 megahertz. And then next Wednesday, which is January the 31st, we're meeting at CNS for the first of 2 consecutive weeks between 7 and 9:30 for a social, Bright Sparks and Raspberry Pi applications. So we hope to see you then. Until then, from Tammy M0TC.
Bye.
And from me, David G7RP. Take care of yourselves. Look after each other. Bye-bye.